Today, 12.3, if I multiply the gradient of one tangent with the gradient of a normal, for example, if I just pick any point here and then I place my tangent across like that, it kisses the curve, and our normal is 90 degrees to that. Shh, boys. 90 degrees. If I grab those two gradients and I multiply them, what number am I going to get every single time? A -1. Okay, so you need to be familiar. There is a proof for that, but we're not going to prove that today. You just have to know that that's something to use. So if we come over here, find the equation of the tangent to the curve y equals x squared plus 2x at x equals 1. What is the very first thing that's going to pop out from this sentence here that's going to make you do an action? What action are you going to do, Nathan? Anything. What's the key word that you see in here? Any keywords? It's like a equation, okay? Yeah. I'm after tangent, okay? That's all right. And the word tangent in your head automatically is asking you to do something. What's that say? What's that?
Find the line. It's going to be upward.
Okay. Not quite. That's okay.
Side on curve.
Not quite. Anyone else? Okay. Derive straight away. Okay. You'll get a free point. Even though you have no idea what you're doing, we derive the equation straight away. So if I have y equals x squared plus 2x, okay, my x squared turns to 2x when I derive, Emily, and with what?
+2.
And a +2. Okay, so we've got a derivative equation. We've got equation and derivative equation. We want to find the equation of the tangent to the curve x squared plus 2x. What am I going to do to this derivative equation? Okay, Tim, what do you think? What are you going to do?
Not sure.
That's okay. Who wants to give it a go? Zach, you got any ideas? Okay. What is useful?
We're subbing the x equals 1.
We're subbing the x equals 1 because that's the focal point. So over here, we are focused on 1. We're not focused on any other x value. This is only on 1 point only. 2 times 1 plus 2. Okay, is a 4. So what are we saying? What does this mean in English? On our graph at x equals 1, the tangent is a 4. The gradient's a 4. This will all make sense in a second, okay? We're just going to build it up. So we now know that the tangent gradient is 4. It's the same thing. Okay? But as I think Nathan highlighted, after the equation of the tangent, what is a tangent? What is it? When you look at a tangent, what is it? It's a line. So then you get your mx plus c. Jesse, what can I change this now to?
Change the m to 4.
Change the m to 4. For x plus c. Okay. We'll keep going. What are we going to do next? This is where it can get a bit tricky. What are we trying to find out here? We already know the gradient, it's 4. We're trying to find C. We're trying to find that. How do I find, I've got 3 unknowns here. I'm trying to find C. What can I do to make sure that we've only got 1 unknown? What can I do with the y and the x? Okay.
You can put y into the next equation and find y and then put this in.
Excellent, Maya. We know we're talking about 1. If I put 1 in here, I'm going to get a y. Okay. And we've got a 3. So what does that mean? At x equals 1, y equals 3. I've now found, Maya's now found a useful x and y that go together. And we can punch it into here. So now we can do this. Now we can do that. Now we know it's a -1. So the equation of our tangent is 4x minus 1. Okay? Any questions? Let's go a bit further. We'll graph this up. So hopefully you've got your CASs today. If you don't, you can look on my TV screen. Next question. B is find the normal. What I mean by that is find the normal equation. So I now know y equals 4x minus 1. I want to find the normal. What must I do? It's a normal equation. It has its own gradient and it has its own y-intercepts. How can I find the gradient of the normal based on information in here? What can I do?
You have to do like so times the percentage one.
Correct. Good say. We know from before the 2 gradients are related to each other. It's a -1 relationship. It's a bad relationship, -1. Okay. One person's going that way, the other person is going in a completely different direction. It's a negative relationship in a way. Okay, so we can work in this 4 here. 4 times our gradient of the normal. Therefore, what is the gradient of the normal equation? Manny. Opposite of timesing by 4 is? Dividing by 4 on the other side. Okay, so the picture's unraveling at the moment. So we have this as our equation. Okay. And once again, to find my C, Jesse, what am I going to use? What was over there?
Yeah.
Correct. That's what you're thinking? Okay. So our C is a 3 1/4. I'll put them together the other side. So my full equation is -1 on 4x plus 3 on 3 1/4. Okay. If you want, you can change it to improper. 3 times 4 is 12, plus 1 is 13 on 4, which makes it a bit easier to put in your calculator. What I want you to do now, can you punch in y equals x squared plus 2x in your first equation? Y equals 4x minus 1 in y2. And then for y3, our normal. Can you do that right now? I'm going to show you what's happening on the screen. Mm-mm.